Yo, they're back at it. All right, so doing a quick video tonight. After watching some sound advice, I noticed that there was some topics coming up that I thought I could shed a little light on. So the first one being modeling software in general, but more specifically, how to simulate cabin gain in WinISD. So there is some other programs out there that allow you to do it. Mainly, I think the one that recently has caught on a lot is speakerboxlite.com. They have a card feature on there that shows you you could put in a frequency at which your cabin gain starts, and it's just a 12 decibel increase per octave from the frequency that you put in, that you come by measuring your vehicle, your inside dimensions, maybe from all the way in the back all the way up to the front dash, multiply that by 2, and then you're going to take the speed of sound. I know, a little confusing, but take the speed of sound and then divide it by your length there, and it'll give you a frequency. And that's the frequency that your cabin gain technically would start, and you would see that 12 decibel gain per octave on your way down. So technically, the shorter that your length of your vehicle is, the more cabin gain that you would see over the full bandwidth. So you'll notice that as we move along here. So all right, I'm gonna flip my camera around and we'll get going. Open up your WinISD. Now, mind you, this is on a Sony Vaio from 2008. This is the computer I use for my term lab testing and stuff. So it's one of the computers that I use for Windows stuff. So anyways, let's get right into it. Let's just do this quick since I'm pretty good at... Oh, not responding. Oh, don't do that to me now. Hopefully it catches up here. It's been a while since I've used this computer. There we go. Alright, so I believe... You know what, let's just run through this real quick if you're going to add a new driver. I know the specs pretty well for the sub that I'll model. So we'll go Savard, put in your driver details, whatever they may be. And we're going to model the IQ15. It is the D2, it's actually version 2 D2. Then you're going to go ahead and go here to parameters. Now make sure that you have this auto calculate on, so that way the numbers that you put in will auto calculate, and it allows the programming to allow you to input the driver when it's all said and done. Because if you're off by just a little bit, it'll flag you and it'll tell you that the parameters that you inputted were incorrect. So make sure that you have that auto calculate on, and if you can, just keep tabbing through them, and it'll auto calculate them for you. So this is where I usually start, believe it or not. I go ahead and I start here at the X max. So for our driver it's 30. Then next, what I usually do is I come straight over here to the SD or DD, because this is another measurement that you can take yourself and be very accurate with. So I already know that the SD, it's 12.48 inches is the DD, but I think it's 122.11. 12.47, there you go. Okay, then the next thing I input is the power here. And this one's, can't remember what Will rated it at, 1500 or so. I'll just put 2000. I think it takes that all day with me. Then the next one I go ahead and I roll through is the MMS here. It's 319. And make sure that you're the correct units that you're using here for all of these, because if you can click on these and it'll change it to whatever units that you want to work with. So just make sure that you're inputting them with the correct units. I'm not going to put in CMS. I will put in the VAS here, and it's 2 cubic feet. And already see how it derived the FS for me just by tabbing through, and it also derived the CMS and the VD down there on the right. So let's go ahead and keep going. The next one that I usually put in here is the RE, because you can measure that yourself. And this is in series. Even though down there it says parallel and only one voice coil, believe me, just let it ride like this. Input it. As long as the parameters are all inputted the same, so don't put the RE here for when you run it in, if it's a dual voice coil subwoofer. If you run it in parallel, and mine would be different than if I ran it in series. So all these numbers I'm inputting are the series numbers. So that's a key thing to remember. So with this subwoofer in series, it's 4.3. And go ahead and tab through here. Also, I know the BL is 27.19. You know what? I think it's 27.19. We'll see right now. Let's go ahead and do these ones then. QES is 0.641. QMS, okay, I see I was close. 20.76. It was something like that with a 7 in there. Let's see. QMS is 5.471. Or I know my QTS is 0.575. So let's see if we can go backwards with it. And it'll give it to me. 0.575. There it is, 5.584. And see how it also gave me a couple of these other ones here, this RMS number here, which is not the RMS the driver takes, it's another parameter. Now, something that some people do and some people don't, I don't input this number that I'm about to show you, but it's the LE, which is the inductance. Now, if you're modeling a driver that you are going to depend on playing above 250 hertz, I would definitely input this driver. But the way that WinISD calculates subwoofers and the way that inductance works, it can skew the graph and the way that it shows you your transfer function here, which we'll get into in a second. But what you would do would put this number in, and then it says millihenries here. Then over here, this FLE, this is where you input the number that it is measured in. Some speakers do it in 1 kilohertz, some do it in 10,000 kilohertz. So that's the number you would input here, and then it would give you your KLE, which is something that it uses to project the mid band, basically, and up, so that above 250 hertz. But since we're doing a subwoofer here, that you don't have to worry about that. Then another thing that some people forget is double check this here in your advanced parameters. You want to make sure that these numbers right here are this number is close to where you're located at. So this is the speed of sound, and it's based on your elevation and barometric pressure and some other stuff. But this is pretty close to mine. Mine's actually under 1100 feet per second. I'm like 6,300 feet up in the air, over a mile high where I live. So I'm just go ahead and leave it at that. That looks good for now. You can input the dimensions, and if you want to get your measuring tape and do it more specifically, and it'll account for that when you input your box size. It'll take the displacement of the woofer here that it derives, but we're not going to go with that. We're just going to do some other stuff first. So go ahead and hit save. Alright, so file name Savard IQ. Here, let's just put demo after this so I know which one it is if I've already done this before in here. Alright, so then, ooh, that green is popping. Let's change that real quick. Let's do something more neutral. It's not so bright. And this is other things that I would make sure you have on. Your air velocity You could either do it in meters per second or in feet, but just make sure it's on peak, and your cone excursion as well. Make sure it's on peak. You don't want those to be at RMS because it's just an average. If you do the RMS over your whole bandwidth and with your power that we're going to input, so go ahead and put it on peak so that way you know for sure at that specific frequency, or yeah, with the power that you're giving it, that's the limit and the exact max that you would see at that point. So that looks good. All right, brown looks a little better. All right, so we'll go here now and go to our speaker that we just inputted. Go down, and if you want to just mess around with WinISD and see how it works, they have a library full of woofers that it comes with. Is it not there? Oh, you know what? I might have not put a manufacturer name, so it's in here somewhere. Yeah, see, I've done this before. Genesis, Eddie IQ, custom. Huh. Where did I put it? In this one? No. IQ V2D2. There it is, demo. See it? All right. There you go. See how it says driver data integrity checks okay? That means the parameters that we put in, the system, the software is saying that it agrees and that is a solid woofer, or that they all match. Just by putting some bogus numbers in there, the program will tell you, no, there's no way that those numbers match, and it'll give you an error, and it'll tell you, once you click on it, it'll tell you what errors and what parameters that were errors. So let's try to speed through this so I don't make this video too long. So we'll just model one driver, and we'll do a closed box first, 0.707, and let's demo. All right, so there's our transfer function, and you know what? I think it was better to see the numbers on here with the different color. That's probably why I had it. There you go. Okay, so that's the sealed. So we'll just run two real quick, just so you can see the difference in them, and I could show you some other specs that are some other of the things that you could use on here, other graphs, and I'll do it with a vented enclosure, so that way we can compare them. All right, and Chevy Cheb. That's a recommendation of what they think the program thinks the woofer would do the best in. Sometimes it might be on Super Boombox. These are other alignments that you could use, but for this we'll just go with what they said on there. Demo, just put V so I know it's the vented one, and let's change that color so we can, there we go. Sorry if my computer's shaking a little bit. It's the I'm having it on like a little desk so you guys can see it. Now, what else do we have here? That does not look correct. Why is my... Do something wrong? You know what? I think this is 0.54. No. Okay. Let's do something real quick. No, you know what? Let's just roll with it. This is just to show you an example. But I think I did input a spec wrong in there somewhere, because this is not usually what the Chevy Cheb looks like. It's a flat response like this one is, and it shows you the enclosure that would be best for that. Yeah, see, that looks a little off, but you'll still get the picture with what I'm going to show you here. So besides all these in here, go ahead and play with them, and it will, you know, tell you what size your vent needs to be based on, you know, your box size that you have here and your tuning. So for this driver, let's just say we put it in a 3.5 cubic foot enclosure, tuned to 31, and which is probably common for what people might run this in. And let's do actually a 4 by 10, which is what is recommended, I think, on the website, but depending on how much power you're running, you're going to need a lot bigger vent, which we'll show here in a second. So, but this is what we came for. This is what I really wanted to show you guys, and this is the cabin gain prediction that you could do using this software. So in these filter types, not only can you put in a, like my amplifier has a fourth order Butterworth crossover on it, and let's just say 150 hertz, and we'll add a subsonic filter, which is a high pass, and also it's fourth order, but I don't run one unless I'm doing major power stuff, but we'll get into that in another video. But we'll add that. It's 10 hertz is the lowest I could add on that. But here we'll also, actually let's put in a power here. So we'll say we're feeding this speaker 2000 watts. Now this voltage you see here, that's based on the series resistance, or the series DCR that we put in when we were inputting the driver. So don't get confused with this voltage. If you want to go back in there and maybe your manufacturer shows them in parallel for some reason, when you put in your power here, this voltage will be more of a number that looks realistic to you normally, like it'll, you know, be in accordance to what the resistance is for being parallel. But anyways, let's go back to what I was doing here, which is the transfer. This is what it's called, a Linkwitz transform filter. So these are other filters that you can add, like a static gain. Let's just say you have a EQ, or you just want to give yourself an actual, you can create your own equalizer. Basically, you could tell it what center frequency, how much gain you want to give it, what the Q was, and it'll model that as well. But for this specific one, we're doing a Linkwitz transform. So what this is telling you the shape of the roll off, or the gain you're getting. The 0.707 is a 12 dB per octave. This frequency is where your vehicle, when we did the math to figure out what frequency your cabin gain would start at. So for my vehicle, it's 57. And then this is the frequency that you put in to where you want it to kind of stop at, I guess is the best way I can explain it. I put this at 15. So some people put it at 20 because they think that's the lowest you could hear, but just because you can't hear it doesn't mean it's not doing something. So even below 20, you're still moving air and you're still shaking stuff, but you're just not hearing it in your ear. You might just hear a lot of mechanical noise coming from your subwoofer if you don't have it in the correct enclosure. But anyways, that's another argument for another time. So 15. So here we go. And as you can see how that the shape of the curve, I mean the shape of the transfer function changed. And now this is accumulating for what you would actually see in your vehicle. So look at the difference here. So this is what our box volume is. So say I put this in a 1.7, right? Look how small that you could actually make your enclosure. And technically, you know, with a little EQing, maybe you like this little punch, extra punch here at the top end. But look, you're still getting all the way down to, what is this? 14 hertz at a -3 dB. I mean, at a -3, at an F3 point of that. So this is pretty close. I wouldn't say it's spot on. It really depends on how dialed in you are with your measurement when you're doing it. But this is the way that you use it in WinISD. So look at the shape of that, okay? And then if we didn't use it, look at what this program models based on the size of the box with that 1.7. Okay? Now, this is something that I thought was pretty cool. Let's turn this one off, and we'll mess with this sealed enclosure. 4.27 for a 0.70, so that's pretty close. So this is pretty close to a 0.707, which is ideal to get the roll off 12 dB per octave, and that's why in a sealed enclosure, most people would, if you didn't notice already, that it plays pretty flat in a vehicle, and that's because even though your F3 is a lot lower in a sealed enclosure, when you add your cabin gain, you will pick up all this low end stuff over here. So you know what, let's turn this on so I can show you what I mean. So we'll turn off the filter though, and we'll put our box volume back at what we had it, 3.5. Okay, now we'll go to our sealed enclosure, and to do the same thing, just to show that it's a fair comparison here, I'm actually going to be adding a crossover on the bottom end, which in essence, every 2 orders or that you add in a high pass or infrasonic filter, if you want to get technical, is going to be another 12 dB per octave roll off. So here we will actually see this steepness of the response in the roll off on the sealed enclosure here will actually drop down and get even steeper. Oh, dang it, I did it a low pass on accident. All right, I'm actually going to have to delete it first. Okay, so let's change this to high pass. And 4th order. And 10. Okay. Now we will add the liquids transform. And we will put 57, 15. And see that? Look at the gain it gets now. So if you want to do it how most people do it, I think they do put this down to 20. So let's see the difference. Okay, not as extreme because it's not giving you any of that effect below the 20 hertz mark. So most people, you know, aren't playing below 20. So I guess that is a more realistic for listening purposes. But you know, guys that are nowadays doing the ground and pound playing 415s or 418s, they're showing off and showing their, you know, their 15 hertz flex or 18 hertz flex. So let's see, let's change this to 20. But this is how you use it. So you can put in your frequency that yours starts at. Maybe yours is 45 hertz, maybe yours is 63 hertz, and it'll change that curve based on that frequency. So here's what most people would say. Let's do this. So that ported box without the liquids transform, 3.5, 31 hertz. Still a pretty good response as far as the F3 point. Look at that, 25. Okay, and giving you around a 3 dB, which I would say most people are trying to stay under or around for a daily box, for, you know, not an SQ build and where you're trying to stay at the 0 mark the whole time. But nowadays this is what people are suitable and are happy with. But see, it's showing this is what your response would be like. Now compare that to the sealed. This is what you're actually getting, which, look how much lower you're playing down here. Now if we take off the filter, that's what it's saying you're getting without the filter on. So definitely a powerful tool that you could use, and it works kind of similar with that speaker box light I was talking about. And a quick other one I want to show. Oh, before I forget, okay. So when you do use it in WinISD, this transfer function filter, the thing that you need to understand is based on actually I need to use this one because I put the power input in there. Based on the way the software calculates stuff, your cone excursion and your air velocity are going to be so increased that it's not accurate. So for instance, look, we'll go to cone excursion, and look at this. It's saying it's way, beyond what the woofer is able to do. But when you take it off, see, that's what it's actually. So when you look at your cone excursion and same for the port velocity here, watch. See, that's why I said that you need a much bigger port for the amount of, well, I did put, to be fair, I did put 2,000. So let's put 1,200, let's just say. Let's see where that gets us. So with a single 4 by 10 inch port, you're still below that 33 or so that most people try to stay under for maximum, with in a car, in a trunk, you're not going to hear that. Maybe if it's in a SUV, in a more sound quality situation, you will hear that. Most people try to stay below 18 meters per second to guarantee that they're not going to have any chuffing. At this 33, you are still going to be losing a lot of output due to port compression with that amount of power going through. But will you hear it? Some will say they can, and in some situations you can. But I know a lot of manufacturers, when they suggest a ported enclosure, the vent mock that they're suitable with in being the maximum is that right around that 32, 33-ish. So there you go. That's, that 4 by 10 port would work in this situation. But to show you with the filter, if you add in the Linkwitz transform, it just goes off the map. So it's just something to take into consideration. Make sure you're clicking that on and off whenever you're looking at those two functions, the air velocity and the cone excursion. Also, I believe the SPL goes off when you do this one as well. Well, actually, that's more accurate. The SPL works good. That usually is in tandem with the transfer function. You could see that same type of response in the SPL. So, let's see. Does group delay get changed here? It does. So also the group delay changes. So be mindful of that. So as you can see, this one, usually I try to stay below 30, at 30 and below. So this is a little big of an enclosure, I would say. The smaller the enclosure, the less group delay you're going to have. So I'll show that here. See that? So I personally run the high Q in a 2.7, 28 to 31, somewhere in there. That's kind of a sweet spot for it, for the high Q15, in my opinion, on around 50 square inches of port. Now everybody else's is going to work differently in their vehicle, but that tends to work well in mine for a single driver. So I hope I hit some of these key points. I know I talked a lot, and there's a lot of info in here with this program. And if you would like me to go into more detail in a future video and kind of break down all of these are powerful functions that you could use, from looking at your transfer function phase to seeing when you're going to be in phase. If you're kind of a burp guy, that's one you really want to look at. Group delay is more for your SQ guys. Maximum power, maximum SPL, I really don't use these at all. These are based on the manufacturer's specs, and in everybody's vehicle it's going to be different as far as the thermal capacity and how loud it gets before you reach cone excursion, because everybody's cone excursion is actually going to change in their vehicle than what you get on this graph here. It changes a little bit. It stays relatively similar though as far as the shape. Also impedance, this is where you could see where your dips and your peaks are, give you an idea of if you're trying to look for efficiency, from where you're tuned at to where you probably want to burp at. You're probably going to be in here with this enclosure. 44 hertz, 18 ohms, that's in series, so you divide that by 4. What are you looking at? A little bit over 3. So that would be pretty cool to know, 44 hertz, 3 ohms, that's where I'm going to be burping. And you can use that in tandem with the VA and say, okay, at 44 hertz, that's where I was the most efficient, and I'd be only clamping 289 watts when I'm giving the woofer 1200. So that's a powerful number to use, and a little secret. I'm not going to talk much more about it. And I'm not going to go fully into all these other ones, but believe me, they all have a purpose. These are the filters that you could look at more specifically when you are doing the filters down here, as far as your EQ and seeing what it does with the EQ on and EQ off. But yeah, that's the gain that you get from your cabin and how to use it on WinISD. And before I end, I'll give you guys a little cool look at something. Change my source here. This is another modeling software program I use that probably nobody has, but I was able to pull some strings with some old people I know. Shout out Translex over in Bakersfield, California. I'm not going to say much more on it, but oh yeah, that's right, it just went out recently. But check this program out. Had to do a lot of stuff to get this to work properly, but here, let me zoom in on here. Oh, too much. That's good enough. Alright, so this is a program from 1992, early on in computers, but this is a Blopunk modeling software. So you could put in, you can input drivers, you can, let's see, so I start here, we're speaker parameter database. So scroll the database. Let's see if I have the Savard in here. No? Have my lands are in here? Oh yeah, okay, cool. So here's the Lanzar HRDC12. You can go, let's see. So that's the woofer that I'm using. Then we are gonna go exit, then go back, and you can even do the box that you're going to be putting it in. So we're going to say rectangle box. This is where you get to put in the actual dimensions of your enclosure and stuff like that. You can also do, oops. So this is where it tells you what kind of enclosure it takes. So we'll do woofer 1, and oh, I did have the Savard in here. Okay, so then woofer 2, we'll do the Lanzar. And then it tells you based on the data that you have in there what it finds optimal for it. And I think I might have messed up the specs on these for sure. Look at how small those enclosures are. Okay. Or maybe it didn't even do what it should be doing. There you go. And oops, go to woofer number 2 and go to the box style for that one. There you go. And then you could even plot your response. Boom. So another old school program. I still need some tuning, some tweaks to do with the drivers that I inputted. I think I did it really fast and see how it actually uses it, but pretty cool. Old school program. You could, I mean, really, it has some stuff on here that's way above its, ahead of its time. You could do crossover design stuff. Toyd, if you watch this, you're gonna like this thing. It has some pretty powerful stuff in there, and like I said, you could even show it you could input a lot of your specs. Let me just do a quick one. Oh no. Alright, and enter. Control enter is what it says. Alright, and then you could draw the box. So check this out. Oh. Gives you a cut sheet and everything. So pretty cool. You know, it's ahead of its time for sure. And, you know, let me turn my light on. And wrap this up. All right, so I know it was long. I might drop it in 2 parts or edit a lot of the stuff to make it a little shorter. But I wanted to give you my input on it. Some stuff in there that people probably don't talk about a lot because they either didn't know how to use it or try to keep some secrets to themselves, who knows. But that's what I've derived from using it over the years, and wanted to share it with you guys. You know me. Anybody that wants to learn about stuff or is interested, I'm always willing to share my experience. Not that it's knowledge and take it to the bank, but it's what I've experienced and what I've used in my builds. So, it's Third Era. Appreciate you guys watching. Slap at the base.